The diagram below not drawn to scale, meaning it's not drawn to the exact size. So you can't use any measuring instruments to measure anything. You're not get the correct answer. If they did say that it was drawn to scale, though, you could use any measuring instruments and be able to figure out the answers. So they're saying show us a circle with center O. So you see in the points here, and they would normally have O in past papers. They're saying that EH, where's E? All right, so from E to H and from E to F, tangent. So some of you saw this last week. Well, tangent, that is a tangent. Let me draw a proper circle. A tangent is a straight line that touches the circle at one point. So something like this. But this one has two tangents. Right? So they're saying those things are tangents to the circle. So those of you who have the rules, by the time you hear tangent, you know something about tangents is most likely going to help you figure out one of those answers or by more than one. And they're also saying that FOG, where's FOG? Okay, I need to erase some. FOG, that's from here to there. And JOH are straight lines. Okay, so I'm seeing some stuff going on. I don't know if you all see what I'm seeing, but we shall see. The measure of angle F to E to H, the angle is always in the middle or located at the middle letter, is 44 degrees. So they said calculate given reasons for your answer, the measure of angle EHF. Now, again, as I said just now, when you see three letters, well, I didn't say it like that just now, but I just said was the middle letter. But when you see three letters, use to indicate a middle, like an angle, the middle letter is where the angle is located. Now, at angle H, there are, you say 1, 2, 3, 4, 5, 6. There are a lot of angles going on at angle H. So if you just go to say, probably this angle, that angle, you might just be guessing around. You don't want to be guessing. How to avoid guessing which angle you need to find here? I normally tell students to start from the first letter. So start from E, go down to H, head down to F. So the angle at H is the one that's between E and F. So that's how you be able to identify which angle they're asking you for. Because as I said, there are multiple angles at H. But to know which one they want, start from the first letter that they give you for that angle, go to the middle, and then go to the end, and the H that is in the middle, or the letter H in this case, that's in the middle of E and F, based on how I traced it. That's the angle we need to find. Okay. I'm looking at something here. So this looks like looks like a bit of a book around the block. See, somebody sent me an answer. You sure that's correct? But anybody else, you can send your answers. Remember, question like this is 2 marks. 1 mark is for the correct answer. The next mark is for the correct reason or reason. This line is a chord, right? Uh, did they say both of them came from E? So there's a possibility that we could use there's a possibility, no guess. Okay. There's a possibility we could use equilateral triangles for this. Why? Well, because normally when you have when you have tangents, what did they say here of a tangent in a circle? Tangents meeting at the same point. Their lengths are normally the same, like how equilateral triangles just have two equal sides. So because their lengths are normally the same, looking at from here to there to here, this would form an equilateral triangle. So this angle and this angle here, those two angles would be equal with this chord. So yes, that will normally form an equilateral triangle. Okay, so we know equilateral triangles, two angles are equal. We're not sure where the equal angles are. Well, you could trace a line from the equal sides. So this angle will be equal to this angle. So all we have to do here is take the total amount of degrees in a a triangle, which is 180 degrees. Take away 44 degrees. We'll get 136. And then we will divide this by 2 because those two angles are equal. So 136 divided by 2. 13 divided by 2 is 6. 6 twos are 12. 13 take out 12 is 1. 6, bring it down. 16 divided by 2 is 8. 8 twos are 16. 0. So this angle here will be 68. Of course, this other one will be 16, so we could put it in. I don't know if we need it. So you will get 1 mark for the correct answer, and the other mark is for your reason. What reason did I use? So technically it has to do with the tangents, but that's one part tangents and isosceles triangles. Pretty much. Don't know if I'll be able to fit this in an isosceles triangle. Now, some people would be more detailed. It's your choice. The key is when you are given a reason, you have to say like what rules it use from geometry to figure out your answers. That's what you're supposed to see. So again, I know some of you all know that a triangle has a total 180 degrees. So all 3 angles in a triangle must add up to 180 degrees. And anytime you see tangents, as in more than one tangent, they are normally equal. Once they meet at a particular point, their lengths are equal. So that's why I knew I could have used isosceles triangles, because isosceles triangles have 2 equal sides. Just putting this to represent equal sides. That's 2 equal sides and also 2 equal angles. So if anybody, Crystal, Rennie, Zesho, Laura, Tisha, Caleb, Cindy, and questions or anything of that sort, let me know. You following? Okay. Yeah. Okay, no problem. So the next part of this question is that angle FGH. So G also have multiple angles. So which one of them, as I said before, trace from the first letter, second, third. So from F to G to H, the angle between them This is the G angle they want us to find. Mm-hmm. Oh, I'm telling you all, circle theorem questions takes a lot of practice if you're not that well, as I said, only last week Tuesday I started this. So it takes a lot of practice to see the example. So what is going on or which rule, because there's have more than one line going all over the place. Now, what I know is going to help me. Let me see who would remember this. Some of you did um something in the measurements with what is the name of this line called? It is actually passing through the center. Last week, Tuesday, I think I talked about this with one of those rules. But also on. But yeah, what is that line called? Okay, so yes, it is called the diameter. Um, right. So there was a rule last week that I gave for circle theorem that involves the diameter. Um, just so we can look at that triangle in red there. That's a possible option. Um, so this one we have to do some work around the block. So I might have to, I'm thinking. So there was a rule that says angles in this in a semicircle form from the diameter, the angle that touches the circumference. This is 90 degrees. So this whole angle here that's touching the circumference, because of the fact that this triangle was formed from the diameter, that is 90 degrees. Right? So this is 90 degrees. Now, what's the next thing? What's the next thing? Um, right, the next thing I was looking at, I'm gonna take out this for a moment. We have a radius right here, because remember, once you know where the center is, any line drawn from the center, this point here, touching the circle, that's a radius. So there was another rule. So let me just draw them on the screen for some people who don't really know, but I know some of your supposed to have this from last day. Um, so I'm just putting the first rule that I used there, which was angle at the center. Not angle at the center, angle in a semicircle. So here's 90 degrees because this line passes through the diameter. So that's how I had this 90 degrees here. Now, this other one here is also 90 degrees. But that rule was the one with tangent to a circle and a radius. Right? So when a radius and a tangent intersect or meet at a point, they form 90 degrees. So that's why I know here would be 90 degrees. So since I need this piece, remember this piece is from within the same triangle, right? Let me just trace back the triangle. So you always see a triangle I talk about. This triangle, which is this one I have outside here. In order to find this piece of angle here, I could use this 90 degrees. Because I already, you see why it's good to write down stuff from what you did before? Because if I didn't write down this, then I'll be figuring how I can figure out this angle to figure out this angle, which would have been giving myself more work. But since I wrote it, and it makes it easier for me, and that's what you all could do as well. Right, so this angle again and this other one right here must add up to 90 degrees. So I would take 90 degrees, take away 68, I'll get 22 degrees. So this piece of angle here is 22 degrees. Okay, if anybody have any questions about that, let me know. But we're not done yet. So you might be saying, okay, why I'm finding these things? I have to find other angles so I can figure out this one. So that's what I'm doing right now. Trying to find what I know based on the rules that I know to find that piece of angle at the top. So now we know that this one is 22 degrees. We know this was 90 degrees. So what is the angle at G, roll? What is that angle? The size of that angle at G? Yes, so sorry about that. So we'll take 90 degrees, of course. Remember, this angle here is 90 degrees. So 90 degrees. What are they doing upstairs? So, yeah, so 90 at 22. So 0 add 2 is 2, 9 add 2 is 11. So we get 112, and then take that away from 180 because again, a triangle, all three angles must add up to 180. So that will give us 68 degrees. So this angle that they wanted, this angle that they wanted is 6. So I hope the others understand. Sometimes in these questions, even though they ask you to find something, you may have to do other things to figure it out. So this is okay. I'm just looking at something here, right? But that angle is 16, that's 16. I'm just trying to make sense out of something. I know those two lines are parallel for sure. There's a, aha, these two are parallel. Okay. All right. So yeah, I don't have to take off everything, but the answer again is 68. Now, for this one, we use a couple things. What do we use? We use angles in a semicircle. Right, angles in a semicircle. What else did we use? Um, Tangent on a straight line. So, tangent. Tangent and radius. Sorry, not straight line. Um, Tangent and radius. Now, once you put these things, the teacher always correct me. Yes, I will know because there's only one rule for each of these, right? There isn't any rule that have the same exact name and different things. So each rule is distinct or different. So tangent and radius and angles in a triangle in a triangle. Okay, yeah, so that's part two. We still have two more to go for this question. So people like Caleb, who else I have from 11th? Laura. Do you all have questions? I think I've seen most of the others. Interval. Okay. Okay, so let me know when you're finished writing. Okay, Alicia, no problem. Yes, of course. That's what I say writing. Please let me know when you're finished. Okay, no problem. All right, so I'm going to take all this because for the other two, I would need some space. So I would leave like the important details or angles within this diagram, but everything else is going at this moment. Okay, um, I'll just write them on the side so I don't have to keep shifting around the diagram. So I need to find part 3. Okay, I'll just write this number 3, quick its way out. Just G, H, E, and part 4 or Roman numeral 4, angle G, G, H. Okay, so heading back up. Right, so I need to know where the angle is first before I can even start finding anything. So of course the angle's at H, but H again has more than one angle. But which one? So from G to H to E. So the one this angle, that's 90 degrees. That was easy. That was very, very mess one. Yeah, that angle's 90 degrees. How do I know that is 90 degrees? Again, remember they said that EH is one of the tangents. So EH is a tangent, and from O to H is a radius. And each line drawing from the center of the circle, touching the circle is E radius. So again, when a radius and a tangent meet, it forms 90 degrees, actually on both sides. So that is 90 degrees right there. Because the radius OH and this is the tangent. Okay, I kind of went off a little bit, but that's 90 degrees. So the answer is 90 degrees. The reason is radius and tangent, or tangent and radius, however you want to put it. Tangent. Um, E radius. And that will be 2 marks right there. If anybody have any questions about number 3, ask your question. Don't have no question. There's one more to this one. Angle GH. Oh, okay. Done. Okay. JGH. G to G to H. Okay. This, looking at this triangle here, they want the angle at G. From J to G to H, so this angle. Now, that angle is also 90 degrees. Now, wait, what? Okay. That angle is 90 degrees. Why is it 90 degrees? Because the rule with angles in a semicircle. So GH is passing through the center of the circle, which makes it a diameter. And anytime, right? Anytime we have a triangle forming from the diameter, the angle that is touching the circle, this one right over here, is 90 degrees. So that was one of the circles I drew earlier on. So let me just do another sketch. This is the center of the circle. G somewhere around there. So G is 90 degrees. So this question is interesting. Like the first two questions are the same sizes but different reasons. The second two are the same angle size, but different reasons again. So for this one, it's angles in a semicircle. Angles in a semicircle. Okay. So yeah, we may be able to do another one. If anybody writes, let me know if anybody else wants to. Well. Make sure and ask your questions. If you will be confused, let me know.